out the BSC, then we end up taking out both the BTS and the mobile phones. So no mobile phones can use that network. However, all of the back-end systems, they typically don't have monitoring for this sort of situation, right? This is basically very, very peak usage. They don't test for this all the time in all the places. So this goes without being detected, right? No questions. Yes. I have absolutely no idea. Our belief is that the BSC allocates channels, so it allocates the channel information, and it has to keep those open for a certain period of time before closing them, right? So after it makes an assignment, it will have a timer for, say, 5 minutes, and if that channel is not opened within 5 minutes, it will close that out and then put it back on the queue to be used again. So what happened was we allocated so many channels that the timers never timed out before there were new ones, like new requests coming in. And as a result, either it took down, like it might have been like a small 100 megahertz PC that couldn't handle like more than 8 megabytes worth of requests or something like that. Basically, like the belief is that there were so many requests coming in over the channels that the computer allocating channels ceased to function. No, typically the BTS isn't that intelligent. Typically the BTS only does radio conversion. It only does the layer 1 stuff. And then the layer 2 and layer 3 is implemented further back. That's the usual setup. It allows the cost of the BTS to be kept low, and then you can deploy multiple BTS systems and have only one BSC, which is much cheaper for a telco. They can spend $50,000 or $60,000 on antennas rather than $150,000 at a go. So usually the BTS doesn't have a lot of information on it. So yeah. I'm sorry, I didn't hear the question. Yes, people who are, the question was, are people who are still on call, do they stay up? Yes, the calls that exist, they're existing channels, those don't get taken down. But people who try to make new calls, who have incoming SMS or incoming calls, that ceases to work. So, right, this would be information on the cell that we have over here. It's actually, this is in Hangzhou in China. It's not the correct information. If it was ARFCN 96, I could do this. Instead, it's 623, which is too high. So that's what we would be going after, but we're not. Does anyone want to see the software just kind of running and like dumping out output? It looks pretty awesome. Yeah. Fuck yeah, let's do that. Right. I'm not very good with computers, so bear with me. I need to... for the attacks or for my personal use? For the... Okay, you can all see that. For the attacks, it's a Motorola C123. You can also use the Motorola C118. They're actually identical boards inside. If you go on eBay now, they're probably going up in price like crazy. But yeah, grab these things. Then you get another €5 cable. You should get the good ones that are USB, like this. And then it's this tiny little headphone jack, actually, that works. Right. So, okay. Oh, that looks kind of horrible. Okay, so we start up Osmocom. Oops. All right. Bear with me 1 second. I have to get my demo set up better. Rachel minus A. Okay, so we're running Rachel, we're running our loader, and now the battery is dead, I bet you. All right. There we go. Okay. Okay, so that's loading the firmware. And now it's trying to sync to the right ARFCN, and it's failing miserably. And here you can see it's not working at all when you get that error response 255. But if it was working, what you would see is loads of purple RACH request messages showing up. What's failing right here is the sync request. It's trying to synchronize to the BTS, right? So unfortunately, I need to have at least 60 dBm on power for it to work, and I bet you it's running at like 90. Yeah, 92. So if we all go outside and find where the tower is and I can get close enough, then I can probably show you this attack. I'm actually attacking T-Mobile. AT&T doesn't have a GSM network as far as I know. All right, I'm actually based in Thailand, so I don't know a lot about the American networks. AT&T does actually have GSM. They do, okay, all right. There you go. Okay. So they suck, basically. That's the take-home message. All right. We can go back to the other attacks, which are slightly more interesting. There's the IMSI detach I really want to show you guys, but unfortunately cannot. So the next one, which I'm hoping I can demo for the guy who's doing the IMSI catcher, is IMSI flood. So basically what happens with the IMSI flood is you use the mobile phone to send a very, very large number of location updating requests with a random IMSI value, or basically an IMSI value that's not actually backed up by a real SIM card. And this is all pre-authentication, because what's happening is we're basically just sending our username. It's requesting a password from us, but we've gone already and we've sent another username, right? So the idea is that we want to try and overload the HLR or the VLR infrastructure and take down the network from inside. So if we can knock over their databases internally, then we can prevent other people from associating on the network, making phone calls, or making other usages of the network. Right? So the idea is that if we can take down the back end, nothing else works. Once again, like the reason I actually developed this attack initially was the idea was that people who are going on marches where they were going to be monitored by IMSI catchers would be able to carry basically a small phone like this that would be automatically flooding out a large number of IMSI requests, and that would either fill up or confuse the value of the logs within the IMSI catchers, basically to make that useless. So it was all like pro-anarchy, yay, black shirt stuff. But then I figured out I could actually take down a network instead, and that was even cooler. And I wouldn't piss off the police immediately. So all for that. Okay, IMSI flood. Once again, we use our evil attack phone. It sends an like this does the full RACH, AGCH, LCH handshake. So this actually does open a channel. But then the message that it sends up, the location update request, has bogus IMSI information in it, right? So it goes to the BTS, the BSC, back to the MSC, and then it hits either the VLR or the HLR. So we can target that based on the MCC and the MNC, right? So if we're targeting the T-Mobile network, we'd set the first 5 digits of our IMSI to 56026. If we were targeting AT&T, it would be 560 dot whatever it is that they use. Probably FF for fucking fail. You need to open a new channel every single time. So the question was, can you reuse an existing channel? And unfortunately, you cannot. Once you do the location update request, it will send back a ciphering request. So it'll say, if you really are who you say you are, you should be able to, do this horrendously clever mathematical thing and use your known secret key. And we don't know that secret key. So we cannot actually continue on from there. So the network state machine will try and get us to authenticate. We cannot authenticate, but we actually don't care. We're just trying to get them to waste time. I mean, theoretically, we could just send garbage ciphering information back, and it would have to do the computation itself, which is expensive, before it can figure out that we failed. All right. So the idea, once again, is if we take out the VLR and the HLR, then no other SIM cards can actually use that network. So even though the rest of the network appears to be fine, the SIM card, basically you still have signal, you still are able to turn your phone off and on, do all that other stuff. The problem is you're unable to open a channel, because when you do a location update request and it tries to go back to the back end is down. So even though you can open a channel, you can never authenticate on it, and you can never do anything beyond that. I haven't tried this one in the wild yet. I'm a bit scared to, because I don't want to get arrested. But I did implement it. It's kind of cool. And if the guy doing the MC catcher stuff is not using GSM 1900, I should be able to flood his talk. So come to his talk for my demo. Okay, so we'll skip that. The cool thing is, right, this is, right, so anyway, that's MC Flood. Awesome stuff. Cracking, you can knock over a network using only a small number of phones and a laptop. Pretty awesome. Haven't actually tried it. It should work. If we have a legitimate IMSI, can we do something much cooler? And the answer is yes. Yes, we can do something much cooler. Okay. So getting someone's IMSI is actually very, very easy. There's a lot of online spammers, online systems that you can use for sending bulk SMS. And if you want to verify that the phone number that you have is a real phone number, they'll do HLR lookups for you. So you give them a batch of phone numbers, and they will verify that these are real phone numbers, that they're turned on, and let you know back. They'll also give you additional information. For example, if you want the MCC and the MMC, that's just part of the IMSI, they'll give you the IMSI itself and other information like this. This costs 1/6 of 1 euro cent per phone number. So if you have someone's phone number, you can get their IMSI. And if you have their IMSI, you can keep them off the network. Okay, so what we can do is we can do what's called the IMSI detach attack. So what happened was the idea was that when you turn your phone off, your phone notifies the network that it is no longer turned on and it cannot be reached. Right? Everyone's tried to call their wife while she's out shagging someone else and gotten the phone is no longer available and off the hook. Right? Sorry. Or a similar situation like that, right? So everyone's familiar with trying to phone someone and their phone is not available, right? What causes that not available to trigger is actually that there's been an IMSI detach. So when the phone turns off, it sends a message to the network saying, I'm being switched off now, mark me as not available, right? The beauty of this is it's unauthenticated, right? You only send the one frame saying, I'm now turned off, and it turns off immediately. Right? There's no, well, if you are who you say you are, you should be able to turn on ciphering mode. Right? So this is written into the spec. And what this attack does is it disables that particular SIM card from receiving SMS or phone calls. Right? It was discovered by a Belgian guy, Sylvain Moonart, and yeah, he's very smart.